You are going to be problematic. You are going to be right in the way. You are going to get out of the way. Yeah, we're live. 6:13. Before 7. Actually, I wanted to be on at 6. I wanted to go from 6 to 7. Yeah, sometimes it takes time to get everything going, but that's okay. Today we're just talking about the video that I just posted, which is a Spintron video. That's the first one I've done, so it's very, very cool. While I was there at Brian Tooley Racing, we were doing a bunch of testing. I was doing it with James on that 427. We did a bunch of LS3 stuff and even some LS7 stuff because it's an LS7 short block, so it makes head swaps and intake swaps fairly simple. So we did a lot of that while we were there, though. They were doing testing on Gen 3 HEMI stuff because they're going to be offering some unique camshafts that things that are not done by other cam manufacturers right now. And same thing with their LS stuff. So they're going to be doing HEMI stuff, which will be cool because I think that the HEMI market needs to be bigger. That motor, particularly that Gen 3 HEMI, has all the things that an LS has. It has good intake manifolds, really good factory intake manifolds, has really good factory heads, and they've just gotten better and better. And they have supercharged versions from the factory. They have all kinds of good stuff. So, but they're not nearly as popular as LS motors are. You don't see people HEMI swapping the world. And unfortunately, that's not because it's not a good motor. I mean, it is. It like I said, it has plenty of head flow. It has an intake manifold. It has displacement. It has enough compression. It has all things going for it, just like an LS. And then when you add a camshaft, all of a sudden, you look like a hero. For a long time early on, there really weren't good camshafts for them. There were a few. Comp had some, and a lot of people were using those. But I don't think that they put the effort into those camshafts that they could have, like they put into other stuff. And they've come out subsequently with much better and more powerful camshafts. It just takes more time to develop those. But for a while early on, back in the early 2000s, people were using those. But now that I want to see is I want to see the market get bigger. I want to see the availability get bigger. I want to see more things. I want to see the number of things that we have, like for the LS market. We want to see lots of aftermarket heads, although the problem is, and this is the reason I don't understand why there are so many good LS3 head or aftermarket LS3 heads, is because the factory one's so good. And then a ported version of that one is also really good, even better, able to support a lot of power, able to lead, buildings on a single bound. And the same thing with the HEMI stuff. And the early HEMI stuff, the ones that I did a lot of testing on, wrote the book on and stuff, that head was good. But the later ones are great. I mean, way over 300 CFM grade, and imported for them even more. So getting an aftermarket head to do that, and now we have some aftermarket heads. We have some aftermarket intakes. I'm getting ready to do an aftermarket intake shootout on the Gen 3 HEMI, and we'll do it on a 5.7 and then probably also on a 6.4. So you 6.4 guys that have been asking for that probably will do that. I probably will do that with the guys at Brian Tooley, and or the guys from Summit may be helping me out with a 6.4 test motor that I can run and do a bunch of testing on. So either way, we can run a bunch of intake manifolds. Not that on some of them we don't already know what's going to happen. Like, we know what high rams do versus long runner manifolds, and the dual runner manifold I've already kind of shown on the 5.7. But we need to get specific about things. Hey, what does the 6.4 manifold do on the 5.7 and vice versa? So we need to look at all that. And so I'll be putting those videos up when we do all the testing, and hopefully it'll be a good reference, like the LS intake manifold testing videos have been a good reference for people to come to and go, hey, look, this is what this one does. It's been established. Everybody now knows that. Here's what they do. Other people have done other videos that corroborate this kind of test, and look, the Trailblazer SS does this, the short runner manifolds do this, and we know that, and that's going to continue with the HEMI, but we just want to get specific information, so I'm going to do that. But the Spintron testing was very, very cool because we're looking at something different. We're not really looking at power, although the things that you're finding help tell you why something does or doesn't make power, and also in the case of the Spintron, why things do or don't last, even if they are making power. And this is very important for, we did on the video, they were doing at the time, because this overlapped with while I was there, but they happened to do, on the day that we were doing lots of testing, they happened to do a fairly simple push rod test. I'm like, okay, you guys are going to be swapping those out. I said, okay, that would be a good thing for me to look at, and I could help explain what spintrons do. And then we could actually have some back-to-back data, because like with the engine testing, I like to provide that. So we did get to see that. And the cool thing is, just like with a dyno on a spintron, the question that you answered just brings more questions. Okay, well, the bushrod did that with that spring rate and that camshaft. What happens if we change one more thing? What happens if we change the retainers or the spring profile or the valve weight or any of, the cam profile, all of these things? And then you get into all of these what if scenarios, and you have to ask yourself this. What if we use this other kind of head? What if we use a rec port LS head instead of a cathedral port head with much more valve weight or less valve weight in the case of a hollow stem valve? All of those things are cool. So what do they do? And the nice thing about we don't have to speculate. Like sometimes if we run into valve float on the dyno, we go, well, what is that? Is that rocker instability? Is it push rod deflection? Is it valve spring frequency? Is it valve spring rate? Is it open pressure? Is it seat pressure? Is it, well, what is it? So the Spintron helps you find out about that stuff. It's very, very cool to see. Like on the pushrod test, we were looking for basically pushrod deflection. And the thing that I wanted to talk about also tonight is when we're looking at something like that, there's more to be learned there. So not just about the thing that we're looking at. So if we look at pushrod deflection, it's important to understand the video that I did one or two before this. We were talking about, taking the chunks off of the LS motor, off of the head and the block, and looking in there and seeing piston to valve clearance. Well, when you're talking about piston to valve clearance and the way that we were demonstrating it, like with a checker spring and a solid lifter and all that stuff, we're looking at basically a static equation. We're looking at, this is not dynamic. Even though I was spinning it around and moving it, what happens while the motor is actually running, and we see what the Spintron is telling us, which basically can be deflection in more than one thing. We can have rocker deflection. We can have pushrod deflection. We can have all kinds of things. We can have variance from the timing set. There are lots of things. And so what normally happens is, the thing that's good for people trying to use big cams is we have more piston to valve clearance in a dynamic situation than we do in a static situation, which is good because you want to measure it in the worst case scenario, and you want it to be best case scenario while it's actually running. So, like I tried to run it. I tell the story all the time about running one that statically only had 3 or 4 thousandths piston to valve clearance. Well, dynamically, it obviously had more than that because it ran and it worked and nothing hit and we didn't break anything. So obviously it had another 15 or 20 when it was running because of that deflection. And then that's why people do what they do to strengthen up, to shore up valve train stuff. That's why they run, heavy duty rockers or shaft rockers, why they put different spring frequencies in there so that it's working in the RPM range that you want it to work and it's not causing problems. Why they go to big push rods, big diameter push rods, thicker wall push rods, tune the frequency of the push rod when you're getting really, really nitpicky at stuff. And again, these can be RPM specific. They can be spring rate specific, all kinds of things. They can be camshaft specific. And this is the cool thing about the Spintrons. It can help tell you all this stuff and you can find out. You can also do, like with the guys at Brian Tooley Racing, they can also run competitors' cams. Well, hey, look, this cam makes 5 more horsepower than our cam. But look, here's the reason that it does that. Because it's got a really aggressive ramp rate. It's crashing and everything. That cam's not going to last 5,000 miles. I'm not saying that that's the case, that other cams don't do that. I'm just saying if you find that out, you find out the reason on the Spintron. You're like, hey, look, this thing is like dynamically unstable, which is why it also doesn't want to rev, why it has a lower RPM range, and why they got aggressive on the ramp rate, except that they'd never run that cam on a Spintron because obviously they would have seen that this is really, really problematic. And that's why having more information is always better. So the dyno is obviously good. Having airflow benches is good. Injector flow machine and a Spintron is just another thing that's going to help show you where these problems might arise. And so when you're using a tool like this, you don't want to use the tool so much after the fact. I mean, you will do that if you're testing a competitor's product, but when you're testing your own, you want to design camshafts like they do, put them on the Spintron, test them, and go, oh, look, we need to revise this. Or, hey, look, our modeling that we're now using Spintron data with, our modeling is doing exactly what the design says it's going to do, but you have verified that. You're not just relying on, I get people that want to talk to me about, oh, but in my computer simulation, it makes this much power. I'm like, that's fantastic. And that may be accurate. The problem is that we don't know if it's accurate. It's the same thing when they're developing a cam. If you use the Spintron information to develop the cam and design the cam lobes, and then you actually test it, you've gone the whole cycle. You've done everything that you need to do because you verified, and then you also run on the dyno and see that it makes power and all that stuff. And you could do durability testing, and you could do all of the stuff. But it's another thing. It's another tool that gives you a great deal of information. And I only just tip of the iceberg, just touched on what the thing could do because we ran a fairly simple test on that. What I want to do is introduce people to Spintron, because hopefully we'll be talking more about that, and we can go in more depth on other things when we're doing other kinds of tests. But unless you understand the basics, it's hard to start understanding the specifics, and we will get into that kind of stuff. So that will be very cool. So our poll for tonight is would you like to see more Spintron testing and data? So would you like to see me do more videos on that? Basically. So what do we got going on here? It's a packaging issue with the HEMI. The valve train has some problematic areas. Why don't people do HEMI swaps? It's too expensive. For a long time, that was the case, but you can find HEMIs. I don't find quite as many HEMIs in the wrecking yard as I do LS motors, 5.3s and 4.8s. But let's face it, those are all smaller than the smallest HEMI. So the smallest HEMI is a 5.7 to start out with. So that's going to be your base motor. So really, a 5.7 HEMI, I already know a stock 5.7 HEMI makes more than a stock 5.3 does. And that's even your basic Dodge Ram trucking motor. We are live. Can you adopt me? We just got puppies. Do you sell parts for sale for 3,800? Yes, I'll have the supercharger and pulleys and things like that. Cool video today. Very cool. Still researching Spintron data. Not that interested in Spintron stuff. You guys have to hang on. Just talk amongst yourselves. I'll be right back. I got to go save Milo. And I'm back. Had to rescue Milo. He's good, though. He was stuck outside. It's too hot out there. I was using my infrared heat gun. Laser. 90 degrees. But I was using it outside. I posted up a thing on Instagram today, and I was measuring the temperature because it was like 100 or something, 101 or something today. And I was talking about, hey, I should take the dogs for a walk. But I went out and measured the temperature of the ground because we're always concerned with the dogs when they're walking. It gets hot on their feet. So I measured the temperature of the ground. In the shade, it wasn't too bad. 96, 97. That's not terrible to the touch because we're that hot anyway. But then I measured it in the sun and it was 125. And then I measured the asphalt street. That was 147. So the ground was pretty hot. Then after I went to the store in my truck, and my truck had been sitting in the sun for quite a while, and I measured the temperature of the dash that was sitting in the sun, you know, right underneath the windshield. That was 183 degrees. So fun with your temp gun. It's good stuff. What breed of dogs are they? I have 3 golden retrievers. One of them is 13 and the other ones are puppies. I need a list of 300 parts, 3,800 parts that are available. I have the blower and pulleys. I have the Series 3 Gen 5 blower and a hub and pulleys. And all of that will go together to somebody. What's on the floor? There's all kinds of stuff on. Oh, there's all kinds of stuff on the floor. Currently HEMI swapping an Audi A4. That's good. Your truck dashboard was 183 degrees. Yes, it was very, very hot. It was scorching inside the truck. I didn't measure. It would have been cool to have just an air thermometer in there to measure it, because that gun won't measure air temperature really. But the dash was very, very hot. I mean, you couldn't touch it. It was ridiculous. HEMI Dart with the modern HEMI would be sweet. Yeah, I would actually like to have like a 71 Barracuda. That I think is my favorite. Or a Challenger. I like both of those. That is my favorite body style, other than the Dodge Omni, of course, the GLH Turbo. I like the Junkyard Turbo LS videos. That's what inspired me to rip out my 5.7 Vortec and do an LS swap. Yeah, the thing is, if you're looking at a stock for stock kind of thing, I mean, there is an evolution of motors as we got better. Obviously, you know, the bigger motors are better than the 283, and they're better than, you know, flathead Fords or inline sixes or whatever. And so an LS is definitely better than a small block Chevy. There are guys that would argue that, but there's nothing in the wrecking yard that you can put in that you'll find in a wrecking yard. There's no small block that you'll find in a wrecking yard that's going to make the power that a LS does. That, you know, stock for stock is just not going to do that. Pretty sure I saw a retriever jump into the ocean to play with a dolphin the other week. They will. Our dogs love swimming around, so I don't know about the dolphin thing. Our puppies have never seen anything like that, but and we haven't taken them to the ocean yet, but we will. Can't even imagine what kind of temperature. It was hot. It was very hot. And I measured it several times just to make sure, but you could feel it. It was inside the car. It had to be, I'm sure it had to be as hot as the temperature of the ground was. I'm sure it had to be 140 or 150 inside. And that's not unusual for the inside of vehicles to get that hot. And that's why they tell you not to leave pets in there or little kids or that kind of thing in there. Because if it's just sitting there without the AC or something on, it gets really hot. $1.83. Eric, are you asking me? Yeah, just send me an email. But the blower and the hub and the pulleys and stuff will be like $350. That's our. Oh, look at that, 96%. So 26 votes in. Would you like to see more Spintron testing? The Spintron is kind of cool. It's cool to listen to it go too. It really sounds like it's running a lot of RPM. Because you saw, if you've watched the video, you'll see that when I think it's Ty, when he was first doing it, the way that he had set up, and he can adjust all of this, but when they're running the sweep through, like they run a sweep through like we do. Actually, he's doing a step test, but he's running it up, and as it goes from idle, which is like 1,000 RPM, up to, let's say, 7,000 RPM, the first 6,000, it jumps 1,000 RPM at a time, and then it stabilizes and grabs data points, and then stabilizes and grabs data points. But then after 6,000, then it goes up 100 RPM at a time. So that's really the area where they're more concerned with problems with the valve train, because and then they compare whatever those problems are at each RPM increment point that they took versus what is essentially a baseline, and the baseline is 1,000 RPM. So you're not going to get so very much deflection and disturbances happening at 1,000 RPM. They can, but it's much more rare. So if you don't get any there, then you can compare all the stuff that happens at the other RPMs and go, hey, look, we're running into some weird harmonic thing, because it's not just always like the highest RPM. Sometimes you run into, oh, look, it's got an instability problem, and then it goes away. And then it's like good all the rest of the way out. That's actually not unusual. That happens. Some things happen obviously much more often at higher engine speeds when we get into valve float and bounce and things like that. But like I said, it's very, very cool to see all that stuff. And once you look at it, just like getting the data from the dyno, you're like, oh yeah, I have so many questions. Is there an ideal track temperature, and what should the slick temperature be due after burnout? I'm actually the wrong guy to ask that about. I don't know. I don't know what those are. I haven't had enough. I haven't generated enough data with track temperature and tire temperature. And then one of the things that we do, because I'm more of a road racer, one of the things that we did with road racing was we do take tire temperature, but we take a tire temperature spread across the tire to make sure that we're using all the tire. And then we will adjust our usually camber so that we can try to maximize all of the tire. And then we got to balance. Hey, look, we needed more front negative camber, let's say, because we don't have a good camber curve in the front suspension, which you should have designed in when you were making a race car. But on some applications, like a strut suspension on a Mustang or something, it's just not very good. So they want to run stiff springs, and you want to run a lot of spring rate and a lot of negative camber. And so when you do that, you know, if you stand it up and go, oh yeah, look, we're using all the tires in a turn now. The problem is when you're going straight, you know, you've got angle to the tires. And now that you have angle to the tires, when you are asking the car to brake in a straight line, it doesn't brake in a straight line very well because it's not using all of the tire. So again, it becomes a trade-off to where you're like, yeah, I'd like to go around the corner a little faster, but I'm kind of thinking that braking is really important. And so if you lose, you know, braking zone distance and you gain cornering speed, what is the balance there? It's kind of a fun game to play. Spintron's cool, but I'd rather see a running engine on the dyno. I do like running engines on the dyno. Is there an optimum millimeter turbo for twin turbos on a 5.3 LS with the truck Norris cam? No, there isn't. The turbos that you select are going to be a function of whatever power you want to make. With a truck Norris cam, you can easily make 1,000 horsepower or more. It's just going to take a lot of boost or more boost than it would if you had a bigger cam. But the truck Norris cam would be more responsive. So size your turbos for if you want to make 600 horsepower, then the turbo is going to be really small. If you want to make 1,600 horsepower, the turbo is going to be obviously quite a bit bigger. So you just size the turbos for that. Can you compare stock hydraulic lifters compared to LS7 compared to Johnson? Yes, you can. You could see, you might be able to see if they're pumping up or not. Is that what you're thinking about? I'd have to ask them what the test oil pressure is, because you'd want to see that, I think, duplicated in a motor. Because if it's always at 100 PSI, it's going to exaggerate the things. But I don't think that it is. I would think that the oil pump would go up with engine speed too. But yeah, you could. But the one thing that it's not going to tell you is it's not going to tell you longevity of those lifters. Harmonics are killer when engineering stuff, and I don't fully understand it until I became an adult. But it's everywhere, like buildings, airplane wings, intake runners, everything around you. We as people, we all vibrate at a given frequency. It probably changes, I would imagine, with people. But that's the thing. That's why you can break glass with frequencies. Everything does in an excited form. That's what Hemmel's resonance is. It's a resonating frequency. And it's based on, you know, if you hit a drum, you hit a big drum, it makes one kind of noise. You hit a smaller drum, it makes a different kind of noise. That's a frequency. All of these things, and it is really cool. Which one is physically smaller, an LS or an LT? I've never done a tape measure dimension thing. Overall, what's up? Be interesting to Spintron test vintage small block Chevrolet with vintage Isky cams. They used to get 9,000 to 11,000 RPM. No modern parts. Yeah, I'd like to see that. They would have to be, for those kind of engine speeds, they have to be, solid roller cams and lots of valve spring and all that. Our 413 Max Wedge, we had a push rod dynamics at mid RPM that went away up top. Yeah, that, like I said, that's actually not unusual. We used a shiny push rod test. Did you see where it's rubbing? No Spintron available, but later we also had an electronic dyno that could spin. Brule was telling me a story about the big block testing that somebody was doing, and it might have been, why am I thinking that's even top fuel, but it was one of those things. And they noticed that the push rod had wear marks in it where it's hitting the head. So like, okay, well, we're going to enlarge this hole. And then they ran it again, and the push rod had marks on it where it was hitting the head. They're like, we're going to keep going. This push rod's not going to hit this head anymore. And they kept going. And finally, the push rod, they gave it enough room, and it just bent, and the push rod destroyed itself. So they're like, oh, well, we shouldn't look at that as a bad thing necessarily. The push rod was rubbing up a little bit against this hole in the cylinder head, but that was helping the push rod stay alive. So they just went back and put it back together and like, look, we'll give up whatever maybe power that might be. Because it wasn't like it was depositing material or anything. It just had a little bit of a scuff mark in it. And then that scuff mark turned to damage once they gave it enough room. What they did is they kept giving it enough room so the push rod could get the sine wave in it big enough to break the push rod. So it's kind of cool stuff. I'd like to see a dyno test of a stock motor with boost 30 pounds versus coated piston tops versus coated intake runner, including cylinder head intake runner. A stock motor with 30 pounds would be a terrible idea. Coated piston tops are okay, but I don't know what you're going to see in terms of power or anything. Coating the inside of the intake runner, that's what you're talking about? I don't know what that's going to do. I would be surprised if that did anything. I've seen coatings on the valves to reduce friction on the stem, on the face for temperature, but I don't think you'd see very much there. 5.3 pickup came with a Summit 8414 R1 stage 4 truck cam. Would that work well with a turbo or keep it in a budget build? Every cam would work well with a turbo. In my opinion, a stage 4 truck cam is too big for a 5.3. And so that cam is going to lose power down low. So it's going to be soft with a turbo. The spool up's not going to be great with that camshaft. There are much better choices. Not that isn't a turbo cam. It is, but it's a cam that has pushed power higher in the rev range. And so that means it has less down low. And when you get a cam like that, regardless of whether they label it a turbo cam or a nitrous cam or PD blower cam or centrifugal blower cam, I don't care what they call it. When that happens, when it does that, it has an effect on the turbo. If it loses torque down low, it reduces spool up down low. So that's why I normally suggest just put a cam in it that has good low speed power, and you'll be happy with the turbo. Iski Mega Cam hydraulics. Is it a hydraulic flat tappet then? Have ramps that allow high RPM? But how is the lifter going to be very stable at a hydraulic flat tappet lifter? Is that what you're talking about? So overbuilt, you're going all in on the motorboat sound. Yeah, I don't remember what the specs are on that 8714 R1. Is that, if it's a stage 4 truck cam, is that going to be like a 224-ish or something like that on the intake duration? Our poll is still sitting at 95%. I like that. Iski 280 mega hydraulic cam. I used to hit 7,000 RPM effortlessly. And if you can get the lifter working, a flat tappet, a hydraulic flat tappet has a lighter lifter than a hydraulic roller is. So like 7,000, 7,500, 8,000, even 8,500 hydraulic roller stuff is certainly possible. Obviously, we see that with LS stuff. So maybe the flat tappet stuff with the lighter lifter, maybe that helps. Okay, 226, 230. Yeah, that's kind of right in the range that we thought it would be. Yeah, that's a big cam. That's a big cam for a 5.3. It's definitely going to lose power down low. You used to revved your 76.8 454 to 7,000. Must have had really good cylinder heads on it, or a rising boost curve. Because I wouldn't think that a 280 mega cam and a 455 would continue to make power at 7,000 RPM. 280 is not very big. That's got to be in the 220s at 50, right? .280 mega cam, ISKI. 280 single pattern. Let's see if it gives us a 50 number here. Oh, 232. Okay. So that's a little bit more aggressive than I thought it was. But on a 455, that still shouldn't be a 7,000 RPM cam. If you Spintron, can you compare hydraulic lifters versus solid? Yeah, but you'd have to put the lash in the solids too. But I'm sure that they could do that. And they've run lots of hydraulic stuff, so I can ask Brian and Ty if and when they see compression in a hydraulic lifter. You might not see it if you have oil pressure. My 63 Grand Prix fully ported 71 GTO 455, 66 heads, 270 CFM. I did not bring up ISKI, but yes, HFT, which is required by some rules, hydraulic flat tappet. I do like the weight of those and the solids too. When I ran the solid flat tappet stuff, like those muscle car small blocks, it's compared to a hydraulic roller lifter, it's very, very light. I was on my pedal Harley and the other day and saw a really clean SRT 300. Started daydreaming about turboing. Turbo Hemis work really good. Admiral's in the house. Richard, when are you going to do more Ameribear testing? I don't know. Not saying they would make power 7,000, but you're over revving at the end of the straight. Yeah. And the thing is, most people are revving past the power peak anyways on motors, just so that you can, if you're drag racing, especially just so that you can get the most average power while you're running. Uh-oh, our pole is down to 90%. 90 and 10. The thing that I wish I would have tried, but I didn't have it, I didn't have the right adapter for it, is I want to run a draw through turbo on something. So I just need to get some sort of carburetor adapter that will attach to the turbo. So you're running a much longer duration ISKI custom ground. 1970. That should be, I'm sure, Trans Am or MR4 going for 8,000 to 9,000. It's a big difference between those two. What's a Spintron? If you bought you a dirt cheap engine and a massive super high RPM cam for it, would you try an RPM Big Bang? Spin it until the stock rods come flying out? That's not what's going to allow the thing to rev, though. I mean, you can keep revving it even with a bad cam in it. It will free rev. It will go up there. It's not going to make any power. So when it's hot outside over there, what do you guys do? Never go out? Who are you talking to me? No, I run when it's yesterday I ran, it was 95. I don't take the dogs though. Yeah, it's hot in a lot of places in the United States. The lower half, basically. I know I was talking to my niece, and she was out in like Phoenix, Scottsdale. What do they have? 20 something days over 110. It's pretty hot. Stage 4 cam is too big. What would you use? I don't think you'll be happy with a stage 4 cam and a 5.3 if you're using this thing to daily drive. Not even daily drive, but if you're driving it around, you won't be happy with it. You'll step on the gas and it'll feel less than stock. I would put a Truck Norris or something like that in it. But if it's free and it came with the engine and you're just gonna put the engine in, you could also do that. I'm doing a 454 Gen 4 Speedmaster heads and a camshaft that you've done an older with two GT45 turbos. Two GT45 turbos on a big block can make a lot of power. Love to see a boosted engine with different inlet air temps. How much does it affect horsepower? So I don't know how we're going to change the inlet air unless we run an intercooler and not an intercooler. 32 degrees is ice water, obviously. Today was weird. Because we had to do some stuff at school today, but we got up and it was raining. It only rained for, I don't know, half an hour or something like that, but it's really weird because it was still like that. It's still 100. But we got rain this morning, which it felt nice because it cooled off at least momentarily. But Richard, what about a pair of those on a Gen 3 Hemi? It's the same thing. They're 700 plus horsepower turbos. So you're talking about 1,500 horsepower or so worth of turbos. So if you want that on your Gen 3 Hemi, it will do that. Chevy guy, if that's directed at me, I'm in California. Our poll is now standing at 90% that would like to see Spintron testing. I need to be able to do more stuff because I can't always get on the dyno as much as I want. But I might be going around to different dynos and stuff now too. There's only 3 lights. There's more than 3. So you want to rev something until it breaks. The problem is, and we had to go through a lot of things to try to solve this issue with the Big Bang on the turbo stuff too, is we wanted the strength of the internal components to be the issue. And the same thing with an RPM test. We would want the actual strength of the components, like the snatch load strength or whatever, to be the thing. And to be able to get it there, you're gonna have to do a lot of stuff. Like it's gonna have to not starve for oil. It's gonna have to have the valve train in it. It's going to have things that will allow it to get there and not just be a catastrophic problem that was not caused by an internal strength issue. What's your overlap on a HEMI, or you get exhaust heat, not to mention no gas mileage? Big valves, rings, and good retainers. It takes more than that. I'm not saying it can't be done. It can. All of those things can be fixed, but it's a lot more. It's a lot more than just going to the wrecking yard and getting a motor and revving the heck out of it. Richard, remember I'm still working on an NA tune. What about if you're running an aftermarket block with a roller cam bearing? You want to check the valve train in the Spintron then? Would you want to? Is that what you're talking about? Yeah, I think you wouldn't be able to check your block because unfortunately the block has to be damaged to do the testing because it has to have holes in it. Where can your books be purchased, and how would I get you to sign one? I have some here, I'll sell them to you cheaper than you will buy them. They're available at Amazon and Barnes and Noble and those kinds of places. Small ring pack with a corresponding hone job can help with higher RPM engines. Why is the ring pack and the hone going to change the RPM potential of the motor? I'm betting a 2V crank would let go at 7,500. I don't know about that. I don't know about the RPM thing. How do you run performance stuff? I'm doing all my testing on the engine dyno, so it's a stationary engine. And Admiral, it may be more than that. It may be less than that. I don't know. I know that we've run them to 7,000. Because I remember doing the 2-valve stuff to 7,000. But I don't know where that limit is. The Cobra cranks obviously go way more than that. If the Cobra crank can go to 9,500 and make 2,500 horsepower, I don't know where the just RPM limit of the cast crank is. Engine builder, so pushrod size has been a concern. I didn't realize this until relatively recently, but Brian likes to put bigger pushrods and stuff, and I've never put anything bigger than 5/16 pushrods in any of the LS stuff that I've run. Cast 92 to 04, 4.6 cranks are missing counterbalances in the center. Okay. So did they put those in the cast cranks later on after 04? Comp Cams does have a Spintron. I don't know what their development plan is for all of their cams. I don't know if they use the Spintron to develop all of their cams or test them. So I don't know about that. I know they have one, and I know that they have used it. My thinking is less friction, better sealing, oil retention. The bore is just better engineering life. Okay, yeah, I don't know about that. The rings can unload, so gaps are important on both top and the second. Spintron is a non-destructive test unit. Do you mean that it doesn't destroy things? The Spintron, you aren't taking a completed motor and putting it on the Spintron. That's not what happens. You have a dedicated Spintron block that you've made. Not made, but modified. It doesn't have any water or anything running in it. It doesn't run combustion. The electric motor spins the big motor. The regular motor spins the internal combustion engine, but with no internal combustion. Yeah, the Spintron obviously has the ability to break stuff because it can spin the motor high enough to where it can spin it to whatever RPM you want. Yeah, Admiral, I have to ask somebody on that. I don't know about the cast crank. I mean, whenever you talk to anybody and they're talking about putting a crank in any kind of modular Ford, the 462 valve, they just use a Cobra crank. Is there a spark plug in the Spintron? No, it's not making compression. It's just spinning the motor with an electric motor. All you're doing is looking at valve train stuff. Model train, there's no topic here. You can ask whatever you want, including UFO, Bigfoot, whatever. 80s trivia. Be interesting. Spintron testing single overhead cam and double overhead cam engines. You can Spintron anything. So the guys at Skunk, when I was over there, were running the Honda B and K series stuff on their Spintron. Put a stock 462 valve short block on the Spintron with no valve train. Just spin the crank and stuff to see what happens. Mahovitz might have an idea on what would happen there. I think before 10,000, something bad's going to happen. And I wonder if the dynamics of that, because of not having the combustion pressure, is different for the snatch load on that. I just don't know. Do a Spintron Big Bang. I don't know if they want me damaging their Spintron. Spintron Big Bang. How fast will it go? I'll ask Brian about that to see if they've ever. I kind of want to know what's the highest they've run stuff. What does a Spintron cost? I don't know. Mahovitz has one that he doesn't use very often. So if you want to buy one, you could talk to him. I have an LQ9 putting in a 65 Chevelle. That sounds like a good combination. Looking to have good power, nothing more than a street car. So 706 heads for. Well, the truck North can be good without this. I think that what you're going to find is that thing's going to be detonation sensitive. An LQ9 with 706 heads and a small camshaft are going to be pretty susceptible to detonation, I think. Run one of the Jones inverse radius rollers on the Spintron. Be amazed, real smooth, takes less spring. We need a new pole for the Spintron Big Bang. Maybe we could build Richard one and buy Richard one and build a protective system to keep the Spintron from dying when it breaks a motor. The Spintron's in its own building too. It's like a dyno. It's in its own little cell and has protective glass and all that stuff around. So the people are safe. The 5.3 pickup has 243 heads. Yes, those are really good. People love those heads. They swear by them. So Jim and B&R, I need some heads for the Pontiac for the 350. I need some, what are they, 48 heads. I know the Spintron. Look, our poll is dropping 86% now. I need to find some heads to put on the 350 to make it an HO. I'm also going to have to put some kind of flat top piston in, I'm sure, to actually get it to the compression that they're saying that motor had in 69. Because the pistons that are in it will not do that. You can make a Tremec 5-speed fit. I would just put a bigger camshaft in it than for the 706 heads. And then if you want, you could do some work on the 706 heads. I would unshroud the chambers on them. What you do is you put a 4-inch bore gasket on it and scribe the line, and then you take your cartridge roll and your cutter and go out to that line. It does two things. One, it'll add a little bit of it'll lower the static compression by adding chamber volume, but it'll also unshroud the valve and improve the airflow. Or you could just put 317 or 243 heads on it. Spintron is basically an electric motor with an oiling system, right? Yeah, I mean, it's a little more sophisticated than that, but yeah, that's what it does. You want to build a 12-to-1 464 valve. This 5.3 is a 2008 with a flat top piston. And this is one of the things I'm going to show with that cutaway engine. I don't think, at least the way that I'm seeing it, I don't think that the dish piston and the flat top piston, I don't think that the piston to valve clearance changes at all with those two pistons. Because where that valve hits, I think overhangs the ridge that goes around that makes the dome. I think it hits that. I think the valve is over far enough where it intersects that during the piston to valve interference area. And so I don't think it changes anything. I think if it hits on one, it's going to hit on the other. Engine builder, nice to see Brian doing Gen 3 camshaft development. Hadn't had them on my radar for Gen 3 cams. They're pretty sharp. Looking to do reliable 11 to 1200 horsepower 3-liter. Are those Whipple 426s? So a 426 with a good cam is going to be 600, 700, something like that. NA. I don't know what compression you're running on those, but then as long as the Whipple will support that. 48 or 12 Rammer 3 heads are selling for 900 to 2,000 a pair. Wow. That is lots of money. Why is it the thing that I have and the one that I want is always the expensive thing? I don't want to do a HO 350 like $2,000 cylinder head deal. I would just put aluminum heads on it. Would you like to see more Spintron testing? 88%. 16D ports or 62D ports are a good option. I have to see what the ones I have are. I have 2 sets of 6X heads that I'm selling for a young lady, and then 1 set of, those are 6X, and 46s. Two 6Xs and 1 46. One 6X M4. What is the other 6X? M12. And then a couple turbo 400 transmissions. What size turbo for a 500 horsepower K24? A GT35 82. The aviator intake. I don't know. I think that all of that stuff will do whatever the 112 does. Chevy guy, they did have 243s on 5.3s. 243s and 799s came on 5.3s. Usually they were aluminum. A guy may have put them on though after that. Why do you not like the countersunk Torx cam retaining plate? I don't like using the Torx bits for stuff that you have to tighten pretty tight. On the factory stuff, they're even Loctited in. So when you go to take them off, I've seen people snap the Torx bits. I just like the bolt head on there. There was an oddball 15 D port funnel Pontiac 68 with 72 cc's. How about some Edelbrock heads? Allen's back. LR4, LM7 used 706, 862 heads. The 6 liter was 317s or the iron ones. What do you think about the Phytech Ultra Small Block Chevy intake or Phytech in general? I've never used their stuff, so I don't know. Are a 317, 243 valve sizes the same? Yes. The chambers are different. They're not only different size, they're a different design. Getaway, what's up? ARP studs or stock head bolts. I always put ARP stuff for boosted things. I've also run 10 pounds without doing that, but I like to put ARP stuff in it. I haven't heard from Todd. That's a good point. I'm going to give him a call. Maybe tonight, depending on what time we get off. Other D-ports mentioned used on Pontiac full size. Brian wants to know what would be a good straight drive transmission stock that can go behind a 454. Do you need to do anything special to the 5.3 heads to put them on a 5.7? Nope. All the heads interchange. The only exception is that on some of the big bore stuff, you can't put, on some of the small bore blocks, you can't put some of the rec port heads on because the valves will actually hit. Otherwise, like a 5.3 head on a 5.7, that just bolts on just like any stock head. Let's bolt it on and go. So we're going to close out our poll at 87%. Started out so high with such good intention. Steel power hypertechnic pistons. If I was putting pistons in it, I would do forged pistons. If I wasn't putting pistons in, I would just use stock cast pistons. I don't think I would select hypertechnic pistons for if I know that I'm going to be running boost. Is it worth building a small block 400? It depends on what you're like. How much are you building it? Are you just putting fuelie heads on it and a hot cam it and a dual plane intake manifold? Then yeah, it's good. It works good. If you're trying to do something and put boost to it or make a million horsepower, I don't think that's the one I would start with. Or 250 stroke crank is the most popular 400 Pontiac. I'm going to put together, I think, a stroker 400 because I have a 400 block. Yeah, the forged pistons are expensive. Look at the Summit stuff. Richard, do I need an X pipe? if I've got a 305, I'm going header to 1 into 2 out, and then a cherry bomb off of each outlet. So you have a 305 with a Y pipe going to a single exhaust, or what? I don't understand. Going to a header to 1 in, 2 out. So how you have 2 exhaust manifolds? Where are those going to? Are those going into a single muffler, and then you have 2 coming out of that muffler? I don't understand what you're doing. Use your words. Siamese board is really a big issue with this motor. Not for just driving around. They're not. I don't want to. Who doesn't want to make 1,000,000 horsepower? Yeah, I wouldn't pick a 400 for making big power. Got a stock 5.3, 243 heads, the stock bottom end. What intake do you have on there? Do you have a truck intake manifold or Trailblazer SS? I'm always going to recommend a truck Norris cam for something like that if it's a daily driver. Okay, 305, each side is a header, then 1 inlet, 2 outlet muffler. So do the headers then Y together into 1 muffler with then 2 outlets? Or do you have 2 mufflers where you go 1 in and then 2 come out of each of those? Are there 4 outlets? Are there 2 outlets? I don't know where Dan went. The Rhodes lifter Spintron test, I think, might be a good idea. Does Rhodes lifters make Rhodes lifters for like an LS, like a hydraulic roller? Yeah, Burnsy too. That's right. B&R, what's a 400? What's a 69 400 block worth? It's a manual block because it has the shift fork deal coming out of it. It's not a 4-bolt though; it's a 2-bolt, and it's a standard bore. I know Rhodes has the old school flat tap and stuff. I just wondered if they also had hydraulic roller stuff. You don't need a Y. You've already made a Y out of the muffler. Are long tube headers worth putting on versus shorty? A shorty header usually adds nothing, and it depends on the motor that you're talking about. But long tube headers add power. Shorty headers rarely add power, although they did on the 5.7 HEMI. But that's the only time I've ever really seen that happen. $900 to $1,500. Okay. What size wastegates do you use with your eBay turbo test? On all of my turbo stuff that I have now, we run dual 45 millimeter hyper gates from TurboSmart. Spintron did was cool. Thank you. 2 or 4-bolt really matter on a small block Chevy. Not at the power level that most people are at. The power level and RPM that most people are at. but it always makes me feel better. That's why I like the Gen 6 big blocks so much, just because they're all 4 bolts. If you put together a 2-bolt main for 350 that makes 400 horsepower, you'll never know that's a 2-bolt or a 4-bolt. 2-bolt Pontiac V8 has been pushed to 800. Yeah, I like I said, I'm just because I knew that was going to be the next question. That's always the question that people ask when I tell them about that block is, well, is it a 2-bolt or is it a 4-bolt? One more minute. I'm glad to be here. It's good to be here. It's good to be anywhere. Actually wrenching on your motor. That's good. Yeah, detonation, not good. Not your friend, no matter what it tries to tell you. No, just a little bit will be fine. Mine detonated a lot harder than that. And which I think is going to be my first shirt. It has to be pinging his power. And thank you. And on that note, it's time to go. Thank you guys all for showing up. I will be back tomorrow. Tomorrow, I think probably the first one that goes up, I'm thinking is going to be a Turbo 408 small block Ford. And on that note, I will see you guys all tomorrow.